the product rule for differentiation. Suppose we are taking the derivative of a product of f times g. So we have two functions, we multiply them together, f times g, and we are taking the derivative of the product with respect to x. So that's what the dx means. With respect to x means you are treating x as an independent variable. So that is equals to f of x times the derivative of g plus g times the derivative of f. So I would like to make everything so simple by just saying fg prime plus gf prime. So every time I use a product rule, I will just write down fg prime plus gf prime. So under what circumstances do we use product rule? Let's take a look at the first example. So the first function I have for you is f of x equals to x plus 5 times x minus 5. Do we need to use product rule? This is clearly a product of two functions. The first one is x plus 5, the second one is x minus 5. So this is a product of two linear functions. Do we need to use product rule? The answer is in this function, the answer is no, because let's say you don't know product rule, you never heard of the product rule, quotient rule, chain rule. So let's say you don't know any of this. You just know the basic. So what is the basic? Let's say you are taking the derivative of x raised to the 5th power. So x raised to the 5th. So when you take the derivative, you take the 5 down, right? And then take the 5 minus 1. So the derivative is equals to 5x raised to the 4th power. So suppose you only know this basic. So for the first function, we can do this. So f of x, let's open this up. That is equals to x squared and then minus 5x plus 5x. So they got cancelled, and then minus 25. And then f prime of x, that is 2x. That's it, because the derivative of 25 is equals to 0. So the derivative of x squared minus 25 is just equals to 2x. So this one you don't need product rule. So no need product rule. So if you don't want to go using the product rule, just expand the entire function and then take the derivative term by term. So what if you have a function like this on the right? So you have f of x equals to 4x to the third minus 5x squared plus 6x, and then you have to take this function, multiply a very long polynomial. Now, without product rule, you have to fully expand this function. Yes, you have to fully expand this function, so you are going to get many terms, and then you take the derivative term by term using the simple power rule. But do you want to go like that? Do you want to waste that much of time? The answer is no, you don't have to waste those time. So all you have to do is apply product rule. So apply product rule. So since this function is too complicated, so let me give you two more examples. So down below, so for those two examples, I will show you how product rule works. So for this function, I will just write this down, use product rule. Again, when you see a function, okay, in a function, you have two factors or you have two functions multiplied together and you do not want to expand them. That means use product rule. Okay, so two long functions multiply together, you do not want to expand them, use product rule. So for the first pink function on the left, we have f of x equals to x to the third minus 2 times 5x squared plus 6. So we are multiplying two functions and I do not want to expand them. So in this case, I would like to use product rule. So to maintain a good habit, every time I use product rule, I will write down product rule. So I will write fg prime plus gf prime. Okay, so what is f prime of x? So for f prime of x, so since this is your first time doing this, I will just do it in a slow motion. So fg prime means I need to take the derivative of 5x squared plus 6, and then the f means you are not touching the first factor. So x to the third minus 2, and then I will just write this dx of the second factor, 5x squared plus 6. And then I will do a plus because for product rule there is a plus, and then for g I will write 5x squared plus 6 and then the derivative of f, right, which is x to the third minus 2. Okay, so now you go ahead and take the derivative with respect to x. So f prime of x, that is equals to x to the third minus 2. Still remember how to take the derivative? So for the 5x squared, you bring the 2 down, so you have 10x, and then what power goes there. 2 minus 1, which is equals to 1. So the derivative of 5x squared is equals to 10x. And then how about the derivative of 6? Is that still equals to 6? No. 6 is a constant value, so the derivative of a constant is equals to 0. I don't mind to write down the 0. Writing down the 0 is not wrong. It's not necessary, but it's not wrong. And then plus 5x squared plus 6, and then the derivative of 3x squared, you bring the 3 down, and then take 3 minus 1, which is equals to 2. And then what about the minus 2? The minus 2, the derivative of minus 2 is 0, so you can either write a 0 or you skip that. And then can we call this done? The answer is yes. So for doing this, we already performed the fg prime and gf prime. So this is fg prime and then gf prime. So the derivative is finished. And then when I ask students to do this on exam, I would just ask them to show the derivative. I say you do not need to fully expand the derivative and then simplify the derivative. But when you do homework online and for some instructors, you do have to go all the way to the end. So let's expand the derivative. So f prime of x, so you have x to the third times 10x, so that is 10x to the fourth, and then 0, right? So this, you can just ignore the 0, and then minus 20x, and then plus 5x squared, so 5 times 3, 15, x squared times x squared, so you have x to the fourth, and then 6 times 3, 18, x squared. Do we have anything to simplify? The answer is yes. We have 10 and we have 15, so you have 10 plus 15, so you have a 25 x to the fourth plus 18 x squared and then minus 20x. So this is the answer to the first function. All right, so let's take a look at number 2. So number 2, we have f of x equals to x to the third minus x squared plus x plus 4, and then multiply. Oh, how come I put a w? So that is supposed to be an x, right? Because we do not want to have two different independent variables. So 2x squared minus 3. All right then. What's the first step? The first step, of course, you write down the formula. So the formula is fg prime plus gf prime. Okay, and then f prime of x, so that is equals to fg prime, so you copy f. By saying the f, I mean the first factor, x squared plus x plus 4, and then you take the derivative of g, so that is d dx, 2x squared minus 3, and then plus 2x squared minus 3, the derivative of the first factor, x to the third minus x squared plus x, and then plus 4. All right, and then now we take the derivative. So copy this one more time. I know it's a lot of writing. You have to get used to it. That looks like 4. So plus x plus 4, and then the derivative of 2x squared is you bring the 2 down. So the coefficient now you have a 2 times 2, which is equals to 4, and then 2 minus 1 is equals to 1, so 4x. The derivative of 3 is equals to 0, so you have a minus a 0. You can just, or you skip the 0. And then plus 2x squared minus 3. And then the derivative of x to the third, you bring the 3 down, so this is 3x, 3 minus 1. Bring the 2 down, 2 minus 1 is 1. And then the derivative of x, the derivative of x is a linear function. The derivative of x is equals to 1. Because the slope is equals to 1. And then the derivative of 4 is equals to 0. So now the derivative is finished. So what we did is, this is fg prime, and then this is gf prime. So if you just need the derivative, then this is the final answer, which is what I usually ask my students to do on exams, because sometimes, you know, they got the derivative right, but they expand the derivative wrong, and they usually come back to ask for extra, not for extra credit, for partial credits. So I don't want to, you know, argue with this. So that's why I said on my written exam in class, I would just say write the derivative, but do not simplify the derivative. All right, but you know, you have to go by your instructor's preference. So this one, let's learn how to expand everything correctly. So f prime of x, that is equals to, so you have these four terms, multiply 4x, so you have 4x to the fourth minus 4x to the third plus 4x squared plus 16x, and then, wow, 2x squared times 3x squared, so that is a 6x to the fourth minus 4x to the third, and then plus 2x, the 0 doesn't do anything, and then now for the negative 3 minus 9x squared plus 6x, and then minus 3. Did I do everything right? 6x to the fourth minus 4x to the third plus 2x minus 9x squared minus 9x squared, and then plus 6x, and then minus 3. Let me check the first four terms. 4x to the fourth minus 4x to the third plus 4x squared plus 16x. So everything looks fine. Anything to simplify? Yep. So we have these two. What else? What else? And then we have the square. Anything else? And then we also have the x, right? So we have the x, and the x. Okay. So f prime of x, final answer. 4 plus 6, 10. And then the third power, there are two third power, minus 4 and minus 4. So that is minus 8 x to the third. And then second power, 4 minus 9 is equals to negative I. And then first power, 16 plus 6, that is equals to 22. And then minus 3. Wow, since there are so many terms, I better check my answer one more time before I finish this video. So 4 plus 4, 4 plus 6, 4 plus 6, 10x, 10x to the fourth, found my first mistake. 4x to the fourth, so it's 4 plus 6, that is 10x to the fourth, and then the third power, negative 4 minus 9, hold on. Negative 4 minus 4, so that is negative 8x to the third. And then second power, we have 4 minus 9, that is negative 5. And then first power, 16, 16 plus 6, so that is 22. And then 22 plus 2, 24, 16 plus 2, 18, 18 plus 6, 24. And then the last one is minus 3. So that's the only constant, right? Minus 3, yep. So that's it. So this is the final answer. So we just learned a lesson. When you expand two long factors, always check your work, because you don't want to get points on the derivative but losing point on the simplification. Alright, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe button if you're on your way out. I will catch you all in the next one. Signing out.